Alright, we're going to do some more equations, and these are from section 7.5. And the directions will tell you whether to give all solutions or the solutions between 0 and 360 or 0 and 2 pi, whatever it asks for. It also gives you little hints within the instructions about how to solve them. So they'll say use your identities, your Pythagorean identities, or use the double angle, whatever. And there's different ways. You don't have to. You can approach it in different ways, but just make sure that you pay attention to what it's asking for. So in number 4, for example, it actually tells me to use the Pythagorean identities. And like any equation here, we're solving for theta. So we want to know what theta is, and I think it asks for all solutions to this. Alright, so let's just go ahead and actually I'm going to show you two different ways you could solve it. So the first thing I'm going to do is get everything on one side. So I want to look at sine squared theta, and then I'm going to take my everything over here over to the other side. So I'm going to add 2 cosine squared theta, subtract 4, and set it equal to 0. Alright, if the instructions hadn't given me a clue how to solve that, and I'm going to do that in just a second, I would be looking at this and thinking, and there's no way that I can factor this because I've got sine squared here that I would be breaking up here, and my middle term has got a cosine in it. So at the very least, you need to be thinking, I've got to get everything in terms of sine or everything in terms of cosine. Now, if I go back and I remember that the sine squared of theta plus cosine squared of theta equals 1, well, sine squared of theta is just going to equal 1 minus cosine squared theta, and that's just by isolating sine squared theta. So if I substitute this in to my sine squared, I've got 1 minus cosine squared theta plus 2 cosine squared theta minus 4 equals 0. And then I'm going to combine all my like terms. I've got like terms here. That's going to be cosine squared theta. Got like terms there. That's going to be minus 3 equals 0. So the cosine squared of theta equals 3. Now, if I took the square root of both sides, I would get the cosine of theta is going to equal positive or negative square root of 3. Alright, and I don't know if you recognized it at that point, or if you're recognizing it at this point, or even if you go as far as to plug this in your calculator, you should remember that the cosine of an angle, my range, the value I get out of that, is never going to be more than 1 or less than negative 1. Well, the square root of 3 is over 1. So this isn't going to happen. So that's actually no solution to this particular problem. Alright, the other way you could work it, and I'm going to show you this just very quickly. Alright, so the other way I could work this is if I'm looking at this right here, I could break this down as well. I know that that is sine squared theta, and then if I split that up into cosine squared theta plus cosine squared theta, which I know is 2 cosine squared theta minus 4 equals 0. Well, here, I know that is 1. And when I combine my like terms again, I get cosine squared of theta minus 3 equals 0, and I'm back to where I was there. And so that continues, and you would see either way that there's no solution to that particular problem. Okay? All right, I'm going to keep going here. Alright, so let's look at 20. We've got 2 times sine of 3 theta. Alright, so we've got these multiples of theta. I'm still solving for theta. Still I'm trying to find what theta is. So let's just go ahead and isolate this expression. So we know that the sine of 3 theta is going to equal, when I subtract 1 and divide by 2, it's going to equal negative 1/2. That's just by doing my 2 steps. Alright, now I'm going to write this out to the side, and you certainly don't have to do this, but this maybe help you see what's going on here. If I and let's call it u, it doesn't have to be u, it could be anything, so let's let u equal 3 theta. Alright, well, I know that the sine of u, if that equals negative 1/2, then I'm thinking the sine of what angle equals negative 1/2? Well, automatically, this is like the equations we solved earlier. I'm thinking, if it's negative and it's sine, then I'm looking at quadrants 3 and quadrants 4. That's the first thing you should be thinking. And then I'm thinking, what angle gives me 1/2? Well, the angle that gives me 1/2 is 30 degrees. And if I want that angle coming out of quadrant 3, then I'm looking at 180 plus 30, or 210 degrees. And I'm looking at 360 minus 30, or 330 degrees. And you certainly can use radians here. All right. Remember, if I'm looking for all solutions for sine, I'm using my period and I'm using this integer to just indicate how many ever rotations I want. And then same thing here. All right, now we're not finished with this problem because I just found what sine of u is. All right, but remember that u was 3 theta. So basically what I found is that 3 times theta, this multiple equals all that. All right, same thing. I've got 3 theta equals my other solution. Well, if I'm trying to isolate theta or get theta by itself, how do I do that? Well, I just divide everything by 3. So in this case, theta is going to equal 70 degrees plus 120 degrees times my integer. And in this other case, then it's going to equal 110 degrees plus 120 degrees times my integer. And this is actually all my solutions. This is every solution. And I'm going to go on and take it one more step because I think the B part to this problem asks for just the solutions between 0 and 2 pi, or 0 and 360. Well, once you've got all solutions, it's real easy. Just find everything that fits in between 0 and 2 pi, or the 0 and 360. So if I'm looking at this first solution, I plug in 0 there, I get 70. That's between 0 and 360. If I plug 1 in here, I get 120 plus 70, which is 190. That's between 0 and 360. Plug in 2. I get 240 plus 70, which is 310 degrees. All right, and if I plug in 3, well, that's 360. That's plus 70. That's too much. All right, so that's not going to work. So these are all 3 of my solutions between 0 and 360, or 0 and 2 pi for that theta. And I'm going to do the same thing here. Plug in 0, I get 110 degrees. Plug in 1, I get 230 degrees. Plug in 2, I get 240 plus 110, which is 350. And at that point, I'm done because now everything exceeds 360. Okay? Let's just keep going. All right, we're finding all solutions here. I think we're finding all solutions, either all solutions or between 0 and 2 pi. Doesn't matter. It does give you the hint, though. It says solve by factoring. So if I'm looking at this, I'm thinking, oh, what a mess. But remember that the first thing you want to check for is when you've got 4 terms, you want to check and see if you can factor by grouping. So that's the first thing I want to do. I'm going to group my first 2 terms together, group my second 2 terms together, and then see if factoring by grouping works here. Well, remember that now I'm looking at each group separately. So I'm looking at these 2 terms and thinking, do those 2 terms have common factor in them? Well, yeah, both of them have a 2 in them, and both of them have sine theta in them. So I'm going to factor out my sine theta, my 2 sine theta. When I factor out my 2 sine theta, I'm left with 2 cosine theta plus 1. All right, and this is looking good because that's what I need to get out of this group. And I can if I factor out a negative 1, because when I pull out a negative, that becomes a positive 2 cosine theta plus 1. And that's what I'm looking for. I'm looking for the same thing coming out of each group. Then I know it factors, because now I'm looking at the whole thing and going, well, this has a common factor and this has a common factor. And the common factor is 2 cosine theta plus 1. And when I pull it out of this term, I get 2 sine theta. When I pull it out of this, I get minus 1. So this whole thing factored to 2 times the cosine of theta plus 1 times 2 sine theta minus 1 equals 0. Now I'm in the home stretch, really, because I'm going to use my zero product property, set both of these factors equal to 0, and solve them. So cosine of theta is going to equal negative 1/2 on this side, and sine of theta is going to equal positive 1/2 over here. Alright, so just very quickly, we've already solved equations like this, so I'm not going to spend a lot of time on this, but think about what quadrants these angles are going to come out of. If it's negative 1/2, cosine is negative in quadrants 2 and 3. Alright, so I've got to get my angle from 2 and 3. My reference angle is going to be 60 degrees because the cosine of 60 degrees is 1/2. So in quadrants 2, I'm looking at 180 minus 60 degrees, which is 120 degrees, plus all solutions, if that's what it asks for. Alright, and then in quadrant 3, I'm looking at 180 plus 60 degrees, so 240, plus all my solutions. Alright, sine of theta equals 1/2, we know that's 30 degrees, and then sine is positive in the second quadrant, so I'm looking at 150 degrees plus 360 times my integer. Alright, and I'm not sure, like I said, if it asks for 0 to 360 degrees, those solutions, or if it asks for all solutions. But remember, if it just asks for 0 between 0 and 360, just plug in, it's just asking for these values right here. Okay, you don't have to give me every solution. Alright, and then we'll do one more. Alright, so this is one of those where, again, the hint is in the directions. I think it tells you to either use the double angle or half angle formulas, and you're going to have to either look back, or you should know them. You're going to have to know them for the test. But my double angle formula for sine is 2 sine theta cosine theta. Alright, so I can substitute that in. That's what that equals. Plus cosine theta equals 0. Now I'm looking at this and saying, can I factor this? Can I break this up? Yes, I've got a common factor in both. And when I factor that out, I'm left with 2 sine theta plus 1 equals 0, which means cosine theta equals 0, and 2 sine theta plus 1 equals 0. And we've dealt with this one all day, so we've got sine of theta equals negative 1/2. Alright, and we've got cosine theta equals 0. I don't know why I wrote that again. Alright, so let's just do the solutions between 0 and 2 pi for this one. Alright, so my solutions right here. This is coming out of the third quadrant and the fourth quadrant because it's sine, and those are the two quadrants where sine is negative. So we've got 210 degrees and we've got 330 degrees. And remember, you can write that in radians too. Alright, and just convert it. If you're not liking radians, use degrees and then convert it to radians, or vice versa. It doesn't matter to me. Alright, and then over here, the cosine of theta equals 0. Alright, so where is that? Remember that my quadrantals, my cosine value is my x value. Where is x 0? What's 0 up there? It's 0 down there. So that just means 90 degrees and 270 degrees. Or pi. I should probably pi over 2 and 3 pi over 2. Alright, and keep going. Alright, if I'm doing this one, that's 30 degrees. So we've got 7 pi over 6 and 11 pi over 6.